13.3 is about permutations and combinations. We'll get more into that. I'm not real worried about the absolute formulas of it. It's because it's a lot of calculator-driven stuff, so we'll talk about that a little bit more in class. But how many different lunch specials are possible out of this menu? Well, let's count each one. There are 1, 2, 3, 4, 5, 6 sandwiches. There are 4 sides, and there are 1, 2, 3, 4, 5 drinks. So all I'm going to do is go ahead and straight multiply these together, and that gives me 120 possible combinations. Now obviously if you're just picking at random, that's what it is. Problem 2, you download 8 songs on your music player. If you play songs randomly, how many different ways can the sequence of songs be played? Well, it's using the same thing we just talked about, that fundamental counting principle, but now we're talking about 8 songs total. Now I can go 8 times 6, 8 times 7 times 6 times 4, 5 times 4 if I want to, but there's this thing in our calculator called a factorial, which is an exclamation point, and that's the easier way of doing it. 8 factorial actually represents 8 times 7 times 6 times ... 2, 1, all the way down to 1, and that's going to give me 40,320 different combinations. Problem 3 and problem 4, we're talking about permutations and combinations. Now permutations are what they call NPR and combinations are what they call NCR, and what you want to do, does order matter? If order matters, we're talking about permutations. If order doesn't matter, we're talking about combinations. So the club is electing president, vice president, and treasurer. We're electing 3 offices, so obviously order matters here because president is different from vice president, which is different from treasurer. So how many different? So we're going to use the NPR here, the permutations. Okay, and we're going to use that button on our calculator. Now there's 10 total, so it's going to be 10P, and we're picking it for 3 offices. So 10P3, which gives me 720. Again, it's just calculator. We'll talk about that in class. Now, suppose you choose 4 books to read from a list of 12 books. How many different combinations of books are possible? Now, does order matter? We're taking 4 books out of 12 possible. Order doesn't matter, so we're going to use NCR, which are combinations. Okay, so how many total? Well, it's 12 total. C, how many are we choosing? 4, so it's 12C4, which ends up giving me 495 possible combinations. Problem 5 is talking about which one to choose between permutations and combinations. And again, it comes down to, does order matter? A college student is choosing 3 classes to take during first, second, and third semester from 5 electives. How many possible ways can students schedule these classes? Well, when we're talking about the different semesters, okay, first, second, and third, they're signifying that order matters, okay, because it's different to take a first semester, second semester, or third semester. So we're going to use a permutation here, and it's going to be 5P3, and 5P3 is going to give me 60 possible ways. And B, a jury of 12 people is chosen from a pool of 35 people. How many jurors can be chosen? Okay, well, the juries that can be chosen here, does the order matter when I pick? If I pick you first or I pick you 12th to be in the jury, you're still part of the jury. So order doesn't matter. So when order doesn't matter, that's going to be a combination. Okay, so we're going to go 35C12, and that's going to give me a really big number, but 834,451,800. Problem 6 is putting all of this together, and we're going to use it to find probability. So 3 pool balls are randomly chosen from a set numbered 1 to 15. What is the probability that the pool balls chosen are numbered 5, 7, and 9? So they're giving me specific numbers. So how many total ways are there? Remember, probability is favorable over total. That's what probability is. Okay, so how many favorable ways? Well, there's 3 things that I can choose. So my probability is going to be 3, because I could choose a 5, 7, or 9 for the first one. Then for the second ball, I could choose whatever 2 is left from there times 1. So that's my favorable. That's what I want to happen at a total number. Now, order doesn't matter. how I choose it. So I'm choosing 3 balls out of 15 total pool balls. So it's 15C3. So that's going to end up giving me 6 over 455. Again, plug in your calculator, which is about 0.013 is the probability. 6 over 453 matters too.